During this experience we will perform the Knoevenagel reaction, which involves the 4-dimethylaminobenzalaldehyde, the cyanoacetic acid, and the piperidine as catalyst to obtain a merocyanine dye. This is a green reaction which occurs in water in the presence of a surfactant which produces micelles. This reaction occurs in micelles that are aggregates made of surfactant molecules which can host in a liquid water environment a hydrophobic core. In this hydrophobic core, molecules can be kept in a high concentration and react. So the dimethylaminobenzalaldehyde can enter into it, followed by the cyanoacetic acid and the piperidine catalyst. As a result, the product is obtained, and when its concentration is high, it can start to precipitate. So now we are ready to see the reaction setup. We have several pieces for which needs a lift, a stirrer, a vial and stir bar, a rubber stopper, the clamps, a thermometer, and a beaker for an oil bath. We can now weigh our reagents. We will start by weighing the CTAB, so the surfactant, which is a hexadecyl trimethylammonium bromide salt, which is a cationic surfactant. We weighed 437 milligrams. After, we weighed the 4-dimethylaminobenzalaldehyde. At the end, the cyanoacetic acid can be weighed. We can prepare the reaction apparatus by fixing a clamp and attaching to it our vial. After, the stirrer and the lift are arranged exactly to fit in the center of the position of the vial. So now we introduce the stir bar and we raise the lift to bring the stirrer close to the vial and the stir bar. We switch it on and try to make the stir bar to rotate and to check that it rotates correctly. And now we introduce an oil paper funnel to help us to introduce our CTAB. We can introduce it correctly without any problem and trying to recover all the minimal quantity of this material. Now it's time to put water into our vial. We put two aliquots of 4 milliliters for a total of 8 milliliters of water. Now we start stirring our reaction to ascertain that all the system is working, but we notice that the surfactant does not dissolve. This is quite strange because we are always thinking that the surfactant dissolves well in water. But the room temperature is below the craft point, which is the minimal micellization temperature, which is the minimal temperature at which the surfactant can start micellizing. Below that temperature, it behaves like a normal insoluble compound. We can demonstrate this by taking our mixture, our suspension, and heating into a bath which is brought to about 35 degrees. The presence of a large hydrophobic component in the molecule hampers its solubility sometimes, and suddenly when the temperature is reached, the compound dissolves immediately. The compound suddenly dissolves at once. Now we can introduce the other reagents, always using an oiled paper funnel. First of all, we will introduce the 4-dimethylamino benzaldehyde. Please be careful and recover every portion of the material to introduce into the reaction. And after, we will introduce the cyanoacetic acid, always recovering every minimal quantity of the material we have to introduce. At the end, we introduce a few drops of catalyst, which is the piperidine, a basic catalyst. 4, 5, 6, 7 drops were added. Now it's time to close our vial with the rubber stopper. We try to use one of our fingers inside the rubber stopper to let him fit properly. Sometimes it doesn't work, so it's better to remove and to use again. And it's better to rotate both the vial and the stopper in order to make the stopper to fit properly into the vial. We can start the stirring and we can appreciate that the material is finely divided, giving a suspension, which is taking a slight yellow color. This is already an index of starting of the reaction because it's a deeper yellow color than the faint yellow color of the benzaldehyde. Now we simply need to take a beaker to fill it with a bit of oil in order to have an oil bath. We can introduce the oil bath by raising our vial and fitting it below. We can adjust the position to let the vial to fit well and to stay as low as possible, and we start stirring again. The last operation is to prepare another clamp in order to sustain, to keep a thermometer that can give us the temperature of the oil bath just to control the reaction, to be able to control the temperature. Once we have finished this setup, we can start stirring again and start heating. When we reach 80 to 85 degrees, we have to control the reaction. We reached 80 degrees in about 20 minutes. Now that the reaction overcome the 80 degrees, we need to control the reaction by rotating a bit the knob to stay about at 80 degrees. We can see that at this temperature the reaction now is a fully solution, so all materials were fully dissolved. After 3 hours the reaction becomes yellowish and darker and turbid. After 4 hours it is darker and darker and more orange. While after 5 hours the first solid appears, which is orange in color and abundant. After 1 day of reaction we can see that we obtained a lot of orange material that when we stop the reaction will settle down. The reaction was left to cool in order to recover the maximum quantity of product just by cooling. Now we are ready for the filtration. We set up an Erlenmeyer flask, an Hirsch funnel. We prepare a filter paper, which can be introduced into the Hirsch funnel. We can switch on the pump, open by the knob the water. We can connect water to the system. We will wet the filter paper, and now we can start filtering. Now we can open the vial and filter our material. It is better to use a spatula and suspend the material, and we can filter, and the residual material can be transferred by washing with a bit of water. From time to time, it is better to stop the filtration to remove the connection with the pump and to attach again, because we have the formation of foams, since we are working with water and surfactants. This removal of vacuum should be done several times. At the end, we can observe our product. We can see that we have a very good orange product, which is a solid, a bit wet. Now we can start removing the product from the filter and recover it. We can take out the Hirsch funnel, put away the Erlenmeyer flask, and we can start to recover the product with a spatula. We need to remove the material from the filter and the paper and so on with the utmost care, because we are working with small quantities, and so we need to recover all materials. When working with minimal quantities, like a few hundreds of milligrams of reactants, it is of the utmost importance to recover all materials, even from the material that can be remain attached to the stir bar. With a bit of patience, all the material can be removed and recovered, so at last we can get all the compounds we produced. Now we can start to prepare our TLC using petroleum ether and ethyl acetate for the first TLC, and ethanol and ethyl acetate for the second one. So we will start briefly with two chromatographies. Okay, now we can start to make our TLC. Now we can make two marks, one for each side of the layer, the TLC, and we can join them with a line that should be the baseline where we will put our compounds. After, we can put three marks and mark briefly what compound we will assign for each mark. Now we can make the deposition of the compounds on our TC. We can start with the standard material, the starting material, the dimethylaminobenzoaldehyde as first on the left. After, we have to wash for a while and for 3 times normally with acetone the capillary, and we can make now the deposition of the solid material, the solid we obtained from the reaction, central mark of the TLC. After, we wash again with acetone the capillary. And finally, we can make the deposition of the liquid obtained from the filtration, which was a bit dissolved with acetone to make an homogeneous solution. Okay, now it's time to develop our TLC. We can open the chamber, can open both chambers and insert into them the TLC. Can insert them vertically and close immediately. We have on the left side TLC with a solution of petroleum ether and ethyl acetate 8:2, and in the right chamber we have a solution ethyl acetate ethanol 8:2. The first one is faster to elute because they are two solvents with lower boiling point and more hydrophobic. The second one on the right side is a chamber with ethanol solvent, which is a solvent having a higher polarity. At the end, we can extract the slides and mark the front of solvent onto the slide. Now we can analyze our TLC under UV light. On the left we can see the petrol ether ethyl acetate slide, and on the right the ethyl acetate ethanol slide. Looking at the left slide, which is developed with less polar solvents, we can see that the aldehyde is the only compound that moves from the deposition point, and it is in practice only present in the mother solution. So the solid product we obtain is pure, but it is stacking on the deposition point. So now we can analyze the ethyl C obtained by ethyl acetate ethanol mixture. The aldehyde is still present in the mother solution and runs higher than the solid product. The solid product runs a bit less higher than the aldehyde and is present in minimal quantity in the mother solution. Unfortunately, there is also a reddish line on the top, which is due to the impurity in the solvent in the chamber. Finally, we can determine the yield. We dried the product in the oven and we obtain 0.28 grams, so 280 milligrams. So it's 64.7% of yield. We have finished this experience. Thanks for watching.